Hi folks, Chuck Black here. We're doing 52 weeks of Python. This is week number 6. I wanted to tell you what we'll be talking about this week. For those of you that are eagle-eyed and you look at what we've talked about so far, devices, functions, you may see that there's something new. This L03 is repeated. I realized that it would be very easy for me to teach you how to turn your Python function into a separate module that you can then import. And so I'm going to go ahead and go over that today, probably talk about using packages as well. These are pretty simple and straightforward. More complicated part of it was understanding all the different ways to pass parameters and to receive results back. So we're going to talk about that. Before we did that though, I did want to spend just a minute and clear something up and also spend a moment and tell you what I'm doing in order to add to this class. Now, I think I've mentioned before that what I've done recently is I've implemented these SD-WAN devices, and I wanted to make sure that you understand what I did was I did not actually implement an SD-WAN device. What I'm doing is I am mimicking a particular aspect of how SD-WAN type devices or remote devices may be communicating to your service. If you have a service similar to Quokka or something that's doing monitoring of your network that is at remote branch sites, things of that nature. Now there's a number of ways to do that. You can do it using your private MPLS circuits that you've already created. But if you're not in that situation, you may do what some vendors are doing, and we've actually done this at Tilak Networks where I worked most recently, and also for a couple other significant networking vendors that we've implemented it for. So I know from personal experience that you can do this. And let me show you basically what I'm talking about. Now, in a normal situation that we've talked about, you'll have your application here and it will be running and it will periodically go out and communicate with devices. And so in order to do that, in this particular example, you can see we're using Napalm to talk to networking devices. Now this picture is not complete because, as you know, we're doing hosts and services as well, and we're using different mechanisms to communicate with those services or hosts. But for talking to devices up to this point, we've been using Napalm, and I did do a little bit of netconf with NC Client, but this is communication. The important thing is look at the direction of this arrow. It is the management station or configuration station going out and communicating with the devices in that way. But with remote devices, you may not have a link that allows you to do this, that allows you to initiate communication from the cloud down to a remote branch site. And in those situations, what we sometimes do is we provide another mechanism, and that mechanism would be to have your SD-WAN device in this situation or your remote device use HTTP to communicate to the actual service. And we would call this something like a heartbeat every minute or 5 minutes or whatever configurable interval it might be. It will send back a message that says, hey, I'm still alive, I'm doing okay. And it may include stuff like, here's my CPU utilization, here's my memory utilization, here's my response time, things of that nature. So this is a mechanism that some are using in order to perform this network management, network monitoring, network configuration functionality that we are implementing in Quokka. And so I figured I would add that. So I don't want you to think that I've done any more than that. I'm not implementing any SD-WAN functionality per se, other than the mechanism that that device is using to communicate back to the mothership or the network management station that is trying to monitor it and keep knowledge of how it's doing. And as you can see, I am in my simulation of these things. I have a little application that's simulating them. All it's doing is sending a heartbeat at regular intervals. And as you can see, in certain situations, it's actually failing to send a heartbeat. That's so that this availability graph will look more interesting. And then when I do add to this devices screen the availability and response time and CPU utilization, memory utilization over time, like I have, for example, with services here, you can see on the right-hand side, I have hourly averages. Then you can begin to see these things move a little bit when availability is not always perfect. Anyway, I wanted to give you that little bit of heads up. And the other thing that I wanted to tell you is this: I am building some lessons that I am videotaping myself building Quokka from absolute scratch. So what you've seen when I've gone through Quokka a little bit is I've shown you, okay, well, this is what I've done. These are my threads that are monitoring. This is the actual database stuff that I'm doing. I can't remember, but I think I've probably shown you the very beginning of how you create something for Flask, and that there's not a whole lot of code in here. Mainly it's starting up the threads and doing some housekeeping. That's about it. But what I'm doing instead is I am keeping track of all of my steps from the very beginning. So in this recordings that I've started to do, I'm starting from nothing and I'm creating an Ubuntu VM. I'm customizing it for my own personal taste. I'm installing all the software that I'm going to be using on it. I'm building an initial Flask application, which is about 5 lines of code. And that's where I'm at so far. I'm going to be augmenting that with here's how you would return device information from your REST API. Here's how you do database stuff, etc. So this is something that I'm doing that will hopefully augment your knowledge and understanding of how you can actually get started in doing that. All right, so let's get started talking about modules. Now, what is a module? A module is just a file with Python code in it. So if you stop and think about that for a minute, every single line of code you've written in Python and saved in a file, that is technically a Python module. So that is true. Everything that we've written is not technically a script or a program or whatever. It's technically a module, but the way that we use the term module is typically to refer to things that we are going to import. So here I see there's a module called template, and there's a module called string, and there's a module called random, and within random there's actually a function called choice. So typically what we end up having is we define a module, and inside that module we define a bunch of functions, or just one function even. In this situation there's one main function in tabulate. And then from other code we can then reference it and make use of it. And if you think about what we've done in our previous example, remember all this modules file or module is, all it is it is exactly this functions one that we did the last session. It looks exactly the same. I just copied it and created a new one. And I'm looking at this and thinking, I could really put this into its own file and use it and import it just like we do with these other things. In this way, I'm creating my own module, and I would effectively do something like this where I get rid of all of the messy way that devices were created. Maybe somebody will come up with a way more intelligent one than mine, and I can use that one. So I don't have to have that in my program. Now, my program here doesn't really do much except create them and then print them out in a nice manner, but it's still a good opportunity for us to create a module, which is a separate file that has my function defined in it. So let's just run this. L3 modules, this is what it looks like. If you recall, I've got whatever this is, 20 or so devices that I've created. And so what we're going to do now is we are going to separate this code right here from the module that it's in, and we are then going to create something that has that function in it, and we're going to reference that. Now, before we do that, I wanted to show you that in upcoming lessons, we'll talk a couple about examples of doing this. So in one example, I have a function where I do a connection to a NetMiko device. And so what I do here, I've put the code that actually uses NetMiko to connect to a device. But I've put it in a separate file called connect, and then in my example where I do some NetMiko stuff, all I need to do is say from connect import connect, and now in my code I don't have all that messy connection stuff. I can just call it, pass in the device type information, First I'm doing CSR, next I'm doing Nexus in my own way of defining this connect functionality. And then I'm able to reference it over and over again in other examples. Now, I've mentioned that modules are typically for defining functions that then get called, but that's not entirely necessary. In other words, I can have any Python code inside my module, and then I can then reference it. For example, here I have a Python module, and all I have is a definition of a bunch of inventory, and I can actually reference this if I choose to. Now, what we typically end up doing is we will end up writing a method or a function to give me that information back. And you see in this situation, if I say get inventory, I will be returning inventory. In this example here, you can see I say from L00 inventory, that's the one that we just looked at, import inventory. Well, let's take a look at what that is. I'm going to do Control B to take me to exactly where I defined that. This is what we were just looking at. Here I'm actually referencing this variable that's actually, as you can see, it's a list of dictionaries, and each dictionary has information about a specific device. So in my example here, I'm not referring to a function, but I'm referring to actual data. So you can do both of these things. And then in this, we'll talk about this when we get to it, when we get to Module 2 files. That's where I talk about this. And the NetMiko example is down here, M04 networking, when I get to that. We'll go into these in more detail later, but I just wanted to give you the general idea. So we have a general idea in our minds of what it is that we want to do. What I'm going to do now is I'm going to copy this create devices functionality and put it into a separate file, and then I will reference that. Let me go ahead and do that, and I'll speed it up a bit and talk about it when I'm done. Okay, so let's look at what I just did. I'm going to clean this up a little bit, get rid of these modules that I no longer need. So I took my modules, and remember I deleted all of the create devices code that was in here. I've created a new file. You can see it is existing here under M01 basics, and I'm calling it util just because this might be a spot where I put utility functions. I pasted my code in here, and then what I also needed to do is I'm using choice in my create devices, and I'm using string, remember down here, to do various aspects of creating my randomness for my device name, etc. And so I needed to import those. When we go back to modules, create devices, if you recall, had a red squiggly line underneath it. And so that was because I had removed that function from this actual piece of code. So what I needed to do now is I need to reference my module and the function within my module, and then I can just call create devices. And if I've done this correctly, then I should be able to just run it and get the same result. So we were in luck. I did it correctly. We've run this function, create devices. Now my main program, look at how simple this is. If I had a number of things I wanted to do, but I didn't really care about how I get my devices created, then I've just made this function a lot simpler. And when I would be describing it to somebody, or somebody comes in and is going to maintain this code for me at a later point in time or extend it, then I've made it that much simpler. And I've put these things in an organized manner. I can have other, if I was going to be doing stuff like I did with Quokka, then I might have not only create devices in util, but create hosts, create services, etc. And then I could have that library that has all my utility creation functions, and I could keep this stuff here nice and simple. So this is the way that I can create a module. Now, just for kicks, let's change the way that we reference this. I mentioned before, and I don't know if you remember it, but there are multiple ways to actually specify your import statements when you import things. You see, I've commented this out, and that means PyCharm is smart enough to say, hey, you haven't defined create devices. This isn't going to work if you try to run it. And if I did try to run it, I'd get an ugly error. In fact, if I do it, it's going to come up with this thing right here, and it says name create devices is not defined. Okay, so we knew that that was going to happen. What I'm going to show you is, remember, there's two forms of importing. One thing I can do is I could just say import util. And so this is my local function that I've defined called util. And now the thing is, if I want to reference something within util, then what I need to do is I need to put util dot whatever at the beginning of it. So here I'm importing the entire module, not just one function. Up here, I did just one function. But down here, I'm actually doing the entire module. Now, my module only happens to have one function in it, but here's how I reference it. So if you do it like this, import whatever your module, then you have to do module name dot function. But if I were to back this out, if I was to just, let me do it this way, if I was to delete this and get rid of this line, now what I need to do is I can see, okay, PyCharm is smart enough to tell me, oh, this isn't the way you're supposed to do it. The way you're supposed to do it is like that. And so here's my create devices. So I've shown you how to do this. Let's make sure that I did this correctly. And so it's still working. And when I come back, I'll show you how to turn this into a separate package should you choose to do that. Okay, so we have taken our functions code and we have removed create devices. And now we have a new Python file here that has our code in it. And we're doing exactly the same thing, except we moved this create devices functionality out into its own file. That type of file we call a module. It's just a file with Python code in it. And so here is my modules code that's very simple, not a lot of extra stuff in it. And I put it into a module or file called util. So here's my create devices inside this util module. Now, when you get so that you are building software for larger projects, you're quite often going to require some type of directory structure for organizing your code. Maybe it's to allow different people on different teams to develop different pieces of code. Maybe it's just for organizational purposes, for keeping all of your functionality nice and organized and clean in their own functionality. So what we're going to do is we're going to take this util module and we're actually going to create a Python package. All a package is it's a directory that has Python modules in it. And so what I'm going to do is I'm going to come up here and I'm going to say, give me a new Python package. Here it is. I'm going to call this util. Now this could be dangerous because my file is called util, but hopefully PyCharm will be able to keep track of this. You can see now I have a folder, which is actually a Python package called util. Now, one weird thing that you may have noticed is that Python created this file called init.py, and that is going to be something that's going to be true for every Python package. There will be a file called init.py with underscores before, two before, and two after. So let's look at all the clever functionality in it. There is none. Initially, your init will have nothing in it. You can leave it that way, and it just identifies this folder as a Python package, or you can actually put code in it. You may have seen in my Quokka code, I had an init file that actually has code in it. That's more of an advanced thing that we'll talk about maybe later on. But now I have a package called util. Now my file or module called util still exists, and what I'm going to do in PyCharm is I'm just going to drop this into my util folder. So it's going to ask me, what do I want to call it? I'm actually going to give it a different name. Actually, I'm not giving it a different name. It's just asking me here, where do I want to put it? I'm putting it into util. So I'm going to say, go ahead and refactor this. It's going to look for all of the references to it, and it's going to change those so that it points appropriately. So now you can see in my util Python package, I actually have my util module. When I look at it, it looks exactly the same. If PyCharm has been smart like we think it is, actually it isn't that smart. So it hasn't appropriately made this change. So I'm going to have to change the way that I refer to this. Now, the way that I refer to it in Python, if there's a directory structure, what you would typically see when you're doing things in Ubuntu or in Windows or with your Mac is you'll use either a forward or a backward slash. What we do in Python when we're referring to a directory structure is we just use a dot. That way it's universal. And so here I'm going to say from util.util import create devices. And so it's going to go look in util, and it's going to look inside the module util, and it's going to find create devices. Let's run this just to make sure that it runs correctly still. So good news, it does run correctly. Now, I think what I probably would do in this situation is I would rename this, because we're thinking of something that is we're building that's going to be a little bit larger. Remember, util has create devices in it, and I'm going to call this, instead of naming it util, I'm going to say refactor this to be called create underscore utils. And I'm going to imagine at some point in the future that I might add creation not only for devices like you see here, but maybe also for hosts and services and for other stuff. And we're going to let PyCharm run. And now we have this file has been renamed to create utils. If you look over here in our project folders, we have the file name has been changed to create utils. And let's see if they've done it correctly. Yeah, sure enough, PyCharm has tracked this down, and it's calling it util.createutils import create devices. So what this is telling Python is go to the package, the Python package called util, look for a module called createutils, and within that find a function called create devices. And that follows, here's our package util, here's our module createutils, and within createutils, here is create devices. So this is a lot of stuff to keep track of. Let's just run it to make sure that it's still running successfully. Yeah, it looks good so far. But let's go over once again exactly what we did. The first thing that we did was we created a module that we initially called utils, and it had our create devices function inside it, and that worked. And the next thing that we did, we said, let's give it a little more structure. So we created an actual folder or directory. In Python, we would call this a Python package. It's a Python package because it has underscore init in it. That lets us know that it's a Python package. And within here, we changed the name of this file from util originally to create utils. And within it, we have create devices. And the way that we referenced it is we said from util.createutils import create devices. So that is a brief overview of packages. The most complicated thing that we did, a little bit simpler, was just Python modules, which just have our functions defined in it. And then at the very basic, the last thing that we talked about was just discussing functions. In that situation, we actually had the function within our actual file that was doing this stuff. So this is a more intelligent way to do things. It organizes things. It allows you to share code. It allows you to reuse code. And it keeps you from doing that ugly copy and paste all over and over and over again. So hopefully this makes a little bit of sense. And now that you not only understand how to do functions, but you know how to do modules and packages in Python as well. All right, so as we always do, let's take a few minutes looking at this Quokka application that I've built. for the purpose of helping you to understand how easy it is to build something that is quite robust and functional with the small amount of work and effort in terms of writing code on your part. All it really requires is the basic understanding of Python and then the incorporation of all of these open source utilities that help us to accomplish stuff. So when you look at the user interface for Quokka, this is the main screen. You have perhaps wondered to yourself, where did these devices come from? So I'm seeing some of these devices that are defined, that are out in the Cisco sandbox. There's others that I've artificially created and am simulating SD-WAN type devices. Where did those actually come from? So we're going to look at the code that actually does that, but I want to remind you, and this is what I go over a little bit in the Quokka from scratch stuff that I'm creating. This is the layout of a Flask application, and this is calls itself larger applications. This means if you're building anything other than the most simple Flask application, you may want to build it like this. And the way that you build it is with a directory structure. Your application in your mind, replace that with Quokka. So there will be a Quokka directory. Underneath that will be another Quokka directory. And then within that directory, there will be a file called ___ init ___. So keep that in mind when you look at the Quokka code that we have here. So here's the top level of Quokka. Here's the second level of Quokka, the subdirectory underneath it. And then within that subdirectory, I have all of these other Python packages. We just talked about that. But there's also this file called init.py. And so let's take a look at this init code and see what it does. So first it imports Flask. This right here, because it's capitalized, is telling you if it's following convention, which it is, that this is a class definition. So we will be instantiating an instance of that class. The class is called Flask. All I really need to do is follow this template or boilerplate or pattern, and this allows me to create my application. Now, going down a little bit further after I've included all of my views, etc., the question might be, where do my devices come from? Well, when we come down here, you can see that this is where the code that I'm going to be using in order to import devices. Here I'm importing compliance. Compliance would be OS and vendor. For every one of those pairs, there will be a standard version number that is going to be compliant and also a configuration. And so that's what I'm using to check against. And then also to import services. That would be a definition of what HTTP, NTP, and DNS currently services are out there. And so the question is, where does that come from? Well, you can see and probably infer from looking at this, I'm going to have a file called devices.yaml, a file called compliance.yaml, and a file called services.yaml. In the data subdirectory is where those are going to be. If I were to look here, then you can see, sure enough, here's compliance, here's devices, and here's services. What does devices look like? Devices, I'm using a YAML file for this. It just has all of these characteristics for each one of these devices that I'm going to be reading from. It doesn't have an IP address because we just have this host actual name for it. This is the host name that I'm going to use to get access to it via SSH. So this information is what I'm going to be reading in. You'll notice also I'm reading in the SLA availability and response time. That's what we compare against in those graphs that I showed you. So I'm going to read these in. We're not doing auto discovery of devices because I need to know how exactly to access them. There are usernames and there are passwords that I have to have configured in order to do that. So going back to my initialization code, how is this actually going to be capturing that file, that YAML file, and incorporating it into Quokka? I'm going to dive down into this file and we can look at what it does. Now, first, I'm going to check to make sure that the information is passed in correctly. The next thing I'm going to do, and this is every time I start up, this is probably not what you would do in a real live product, but since this is just a prototype for teaching, then I actually delete all of the existing devices. One of the issues for me, and the reason it's not a production environment type thing, is my devices are always changing and I'm adding and deleting. I'm actually changing the information that I read in as I flesh this out. So I'm deleting everything here. Now I'm going through something that we're going to talk about when we get to the next section in our teaching, where we're looking at how to read from files. But basically, when you look at this, you can probably infer, okay, you're reading a file and it's going to be located in Quokka/data/file name. And this is kind of what we looked at here, Quokka, data, and then the file name. It's going to open this file. And what it's going to do is, if it is a JSON file, then it's going to use JSON library functionality in order to read it in. And if it's a YAML file, which in our case it happens to be, it's going to read it in using this safe load function. And it's going to actually read all of that data in. Now, nicely, because of the way that these Python libraries are written, then what I'm going to end up with at this point in time is I'm going to end up with a Python data structure, which is a list of dictionaries. So similar to what we've done in the training, at this point in time, I have a list of dictionaries. And all I need to do at this point in time is I'm going to actually go a step further. Rather than keeping just the devices in memory in a Python data structure, I'm actually going to use the database and I'm going to write these out. So if I go down into set devices, here is all my code needs to do in order to write this to the database. So you notice this, there's no knowledge of SQL statements. I don't have to worry about that. I've defined the data structures appropriately such that all I need to do for every device is I need to create a device object, and that's what I do using this device class. And then I use my database session to add that row into the database. And when I'm done doing all of that, all I need to do is a commit. So here we have 4 lines of code to enter in all of the devices into the database. That's pretty simple, huh? The last thing I'll point out is this, and don't worry, I'm going to go into these in greater detail as we go through this. But this thing here, device, what is that? Let me scroll up here. So I'm going to look at my import statement and see where I've defined it. Okay, so here, remember we talked a little bit about defining a module with functionality in it, and then we talked about packages. So you can see here in this path, Quokka, what will end up being /models/device. I'm going to import this thing called device. If I look over here in my models, this is Quokka models. You can see I have a file here called device. I'm going to actually click on this to take me to it by doing Control B. This is one of the very nice things about having something like PyCharm to help me out. Now, this is the most complicated file that we have in here. In fact, let me show you my host table. See how simple the host table is? All I really have is an identifier. I have the name of the host. I have the IP address. I'm keeping the MAC address just because I go and do this ARP functionality to get it. There's no real need for that. And then I'm checking whether it's available and what the response time is and when did I last hear it. So here's an example of a class that is actually a table definition for my database, and that's the simple one. Let me show you device. When I go back to device, this has more stuff in it, but things that you will be familiar with. It has a name. The device will have a serial number. It will have an IP and MAC address. I will be inputting the vendor. If I look here, this data that we're looking at is going to be similar to what we're looking at in here. You see there's a vendor, there's a username, there's a password, there's a host name. All of these things are actually in device. So here's my OS. I have this information here. The transport is going to tell me, can I use Napalm or am I going to use NC client, or will this be one of those SD-WAN type things where I get HTTP REST heartbeats? Here's where I record the availability response time. Here's where I keep the SLA, that I can print those nice lines on my graphs. Here's the last herd that I'm keeping. Here's the CPU and memory that I get from Napalm when I do getting the environment from a device. Here I'm keeping information in my device, whether the operating system is compliant or the configuration is compliant. And I'm keeping track of when I did my last compliance check. Here I have SSH information. Here I have some NC client information and the netconf port. And then these things are common, so I don't have anything identifying SSH or netconf or whatever. The host name, the username, and the password all happen to be the same in the examples that I'm using, so I've kept them the same. So this is a little bit more heavyweight of a class, but I did wanted to show you that so you have an idea of what's going on. Remember, if I go in here, I'm doing import devices. If I look at what happens with import devices, I open up the file, the YAML file, and all I do is I load it, and it gets put into this list of dictionaries, and every dictionary is an actual device, has the data for the device. And then I'm going to call set devices. I'm passing in as a parameter my list of devices. So I go down here. Here's where I set the devices, just 4 lines of code. This for loop where I go through and for every single one of my devices. This is just a general for loop for device in devices. Remember, we've gone through this in the training. Then I go through and I create a class object, an instance of an object from this class. I'm passing in device. We're going to learn about this later on, but I think you can get the general idea of what's happening. And if you've done any Python, you've probably seen these things with a capital first letter if you've used NetMiko or Napalm or any of these modules, libraries that help you to do that. This is a class that I've defined. I'm creating an actual object, an instance that is a device, and then I just do an add, and it will add that row, and it will go through this for loop for as many devices as I have. When I'm done, I'm going to do a commit, and that will actually write it to the database. So we've gone through a little bit of what's going on here and the initialization step of creating our application. We've read in from a file our list of devices as well as these other two, and then we've written it out to the database. In the future, we'll be going into this in greater detail. We'll look at other types of objects that we will be dealing with and dealing with the network, etc. But hopefully this gives you a general idea about part of the startup process for Quokka.